Alright guys, so let's talk about domain. And we've already talked a lot about domain, but this time we're talking about them when they're quadratics or square roots and different stuff like that. Alright, so remember we have some restrictions on domain. It's always negative infinity to positive infinity unless, and one of them was if it's a fraction. If it's a fraction, remember your denominator cannot equal 0. And the other restriction that we really used was if it's an even root radical, so like a square root. If it's an even root radical, then we have to set it greater than or equal to 0. And then we saw before the time to be careful of is what if it was an even root radical in the denominator? Well, in that case, we can only have it greater than 0 because the denominator says it cannot equal 0. So let's look at number 8. So we're looking for the domain, of that radical. So we know because it's a radical, it's going to have to be greater than or equal to 0. And so we're going to square both sides to get rid of the square root. So that means that 2x squared minus 5x plus 2 is greater than or equal to 0. Well, I can factor this out. And so simple trinomial. 4 and 1, minus and minus. But remember, we have that 2 out there, so you got to bring it back and reduce if possible. If not, throw it back to the x. And this was still greater than or equal to 0. Well, because of being quadratic, we know that we're going to, it's a rational, we know because it's quadratic that we're going to have to use our interval table to find where it's going to be greater than 0. So because I need to find my x-intercept, so this is just like what we did at the very beginning from here. So find your x-intercept, so find where they're equal to 0. It's going to be at 2 and at 1/2. It's equal to, so I'm going to go ahead and write bracket. I know I didn't do it at the beginning, but I started doing it with the rational ones, and it just seemed to make it easier for me. And then we're able to make our table from there. So we got our interval, our x value, y value, and our sign. And so hopefully by now we've gotten that point. So I'm going to leave you, well, let's go and set up our intervals, and then I'm going to let you work them out. So negative infinity to the smaller ones, and positive 1/2 with a bracket. The 1/2 then to the 2 with a bracket. And then 2 goes to positive infinity. And so pick your x values, your y values, and the sign, and you should be able to solve it from there. Alright, moving on then. Number 9, we have an even root. We got a square root, so we know it's got to be greater than or equal to 0, but it's in the denominator, so it cannot equal 0. So that means that the square root of 4x squared minus 9x plus 2 can only be greater than 0. And so we're going to do the same exact thing we did in number 8. You're going to square it, you're going to factor it, and then you're going to build your interval table to find where is it greater than 0. But remember, because it's greater than 0, the x-intercepts are going to have parentheses. Alright, trying to move us on a little bit here. Of course, the solutions are in the notes, but the notes online do not use our interval table, guys. And so that's what I really like about it, because it organizes it a lot better. Alright, so let's look at this. Alright, and so then the last part here is dealing with some absolute value. So remember, what's inside the absolute value can be positive or negative. So that means then that, hold on a second, sorry. Okay, sorry about that. So because it's greater than, we know that what's inside can be positive or negative, so we're going to set it up as negative 8 is less than the x squared plus 6x plus 1 less than positive 8. So it can be any number between negative 8 to positive 8, because when we take the absolute value of it, I think I wrote that wrong. Hold on one second. Let me check my notes. Okay, guys, so I don't know what happened. I don't even know if you could have seen what I wrote until I just pulled it out, because my computer showed one thing while my iPad showed another. But anyway, so after I wrote that, I realized it's supposed to be greater than 8. So, and I didn't have a greater than 8, so we're going to use greater than symbols this time because I need the numbers to be greater than what's inside there, so I'm going to take the absolute value of them. They're bigger than 8. Alright, so the best way to do this, guys, is completing the square inside. So let's make this inside going to complete the square. So I need to get rid of that constant term. So I'm going to get rid of the 1. Now remember, what you do to one part of this, you got to do to all. And there's 3 pieces to it. So you have negative 9 is greater than x squared plus 6x, which is greater than 7. Alright, so in order to do completing the square in the middle there, I'm going to have to add a blank. And remember, what you do to one side, you do to all. So I have a negative 9 plus a blank is greater than the x squared plus 6x plus a blank, which is greater than 7 plus the blank. And then do your completing the square. Remember, that's b over 2 squared. So in this case, it's 6 over 2 squared. So 3 squared, which is 9. And so I added 9 in the middle, so I'm going to add 9 on both sides. So when I do this, then I get 0 is greater than, this inside's a perfect square, so I'm going to factor it, which is greater than 16. And so when I factor this, I get x plus 3 squared in the middle. Well, I'm solving for x, so I need to take the square root to get rid of it, and I'm going to change colors here. So take the square root. Square root of 0 is 0, greater than, the square root and the square cancel, greater than, but the square root of 16 is plus or minus 4. And so we're just going to solve for x, so subtract the 3. And so we get negative 3 greater than x greater than, now be careful here because you have positive 4 minus 3, and you've got negative 4 minus 3. So you actually get, what is that, 1 and negative 7. So those are going to be our numbers that we're going to use in our intervals. So I'm going to set up my table. So I have my interval, x value, y value, and the sign. And so, let's see, we said negative 3, 1, and negative 7. So it's going to be from negative infinity to the smallest one, negative 7. It's not equal to, so use a parenthesis. Negative 7 to the negative 3, negative 3 to the 1, and 1 to infinity. And then just pick some numbers in each interval. Plug them in, find the y value, and finish solving. Now you're looking for where it is greater than 8, so you're looking for your positives. Alright, so moving on. Alright, so my last one here is just like what we did before, but I'm going to go ahead and get you started because of the fraction thing again, just to make sure that we're good with combining the fractions. Remember, it has to be with 0, guys. Do not cross multiply on this. That only works when it's one fraction equal to another fraction, and these are not equal. There's an inequality symbol there. So that means I'm going to have to subtract. I'm going to subtract that 2 over x minus 1. So I'm going to have 1 over x plus 1 minus 2 over x minus 1. I'm going to go find that least common denominator. I can't factor either of those denominators, so it's going to have an x plus 1. And then I check the second one, it's an x minus 1, and I don't have that already, so it's got to have that as well. So I've still got 2 fractions being subtracted. I know my least common denominator is x plus 1, x minus 1, so I'm going to write that on both of them. And then I'm going to fix my numerators. My first numerator was a 1. It was over x plus 1. What did I multiply that by? X minus 1. So that's what I'm going to multiply the top by. My second numerator was a 2. It was over x minus 1. What did I multiply that by? The x plus 1. So that's what I'm going to multiply the top by as well. And then we're going to combine our numerators over our common denominator. Now I have x minus 1 times 1. And so I can just, well, actually I'm just going to write that out. So x minus 1, and that 1 at the end is by itself, so I'm going to put it in the front. Minus, and then I have x plus 1 times 2. 2 is by itself, so put it at the front. Over my least common denominator. And then we can simplify. So distribute that positive 1. Distribute that negative 2 all over the common denominator. Combine your like terms. So you have x minus 2x, so negative x. Negative 1 minus 2 is negative 3 over x plus 1, x minus 1. And I can't do anything else. So now I know to find those key points. I'm going to use the x-intercept, which remember is where your numerator is equal to 0. So it's going to be where negative x minus 3 equals 0. So x equals negative 3. My inequality did not have an equal to, so I'm going to use parentheses here. My vertical asymptote is where the denominator is equal to 0. So where x plus 1 and x minus 1 are both equal to 0. So at negative 1 and at positive 1, and they're always going to be parentheses because they're vertical asymptotes. And again, I'm going to go ahead and just set you up with your table and then let you go from there. So we're going to set up our interval. X value, y value, and the sign. So start at negative infinity, and let's see, my smallest is negative 3 with a parenthesis, and then my next smallest is negative 1 with a parenthesis, and then I have 1 with a parenthesis, and I don't have any left, so we go to positive infinity. And so again, pick you some x values, plug it in, and tell me whether they're positive or negative. But remember, we're looking for where, what I didn't show was right up here when I moved that fraction over, it made it greater than 0. So I'm looking for greater than 0, which means I'm looking for my positive values. So wherever my sign is positive, those intervals will be my solution. Alright guys, so I hope this helps. Let me know if you have any questions or if you're struggling on some of it, so that I'm kind of prepared for class on Thursday. Otherwise, we're looking at a test beginning of next week. It shows we got 3.7 still to cover, and then we'll be ready for a test. I know the syllabus says the test is Thursday, but obviously it is not going to be on Thursday. But it will be beginning of next week. So we'll talk about it on Thursday when I get back, so I can see what y'all need me to go back over. Alright. Good luck, guys.